Hello guys, welcome to MAThPulse. If you find this recording helpful or interesting, please like, comment if you have any comments, subscribe if you have not, so that every time I post videos, you get notified. So this is the introduction part for real analysis. The part we have to go through in this video are the sets. So what is a set? A set is a collection of objects. So the objects are also called as elements, and they are also called as members. So there are two important concepts, which is the first one is applied when we say if X is an element of X. This capital letter X is known as a set. So this is a set. X is a set. So this is a notation for an element. We say X is an element of X, of this capital letter X. So this capital letter X is the set. Okay. Now this one, this part, we say if X is not, okay, should bear in mind, if X is not an element of X. So we apply this when we say X is not an element of X. So there is this part which is, okay, this one, the first one, the element, not an element. The element, not an element. X is an element of this capital letter X. X is not an element of this capital letter X. Okay. So we say two sets are equal when this satisfies. So let's consider this example. So let's consider these two sets, X and Y. Okay. We say X and Y are equal if X is an element of this capital letter X. Okay. If and only if X is an element of Y. So we say all the elements in X, all the elements in X are in Y. So all the elements in Y are in X. So this is if this satisfies, if all the elements are in Y are in X and elements in X are in Y, we say these sets are equal. Okay, let's consider this example. We say X, this is the capital letter X, is A, comma, B, comma, C. Let's say this is our X, and Y is A, comma, C, comma, B. The arrangement is not important. The important thing are the members of the sets. So, okay, you can rearrange this and say A, comma, B, comma, C. Okay, so we can see that this element in X is in Y, this element in X is in Y, this element in X is in Y. So all the elements in X are in Y. Okay, all the elements in Y are in X. So we then say X is equal to Y. Okay, so this is how we say the sets are equal. So these two sets are equal. two sets are equal. Okay, so there are types of sets. We have an empty set, we have a finite set, we have infinite set. Okay, so we say an empty set is a set that doesn't have elements. Okay, is a set that doesn't or does not, okay, does not have elements. It's empty. Okay, so we denote an empty set as this. This is how we denote an empty set, or we can use these curly braces. So there are no elements in the set. So we say the set is empty. Okay, a finite set is a set that has a set that has countable elements. So you should code this one. This is countable. So when we say it's countable, it means we can count each and every element in the set. Okay, we can consider this example. Let's say A is equal to 1, 2, 3. Okay, so we can count these elements. This is the first one, second one, the third one. Okay, so the set is what? Countable. So it's a finite set. Okay, now the infinite set is a set that is not countable. So if like you can't count the elements of the set, this not countable. So if you can't count the elements of the set, so you can say the set is infinite. Okay, there is a countable set, there is a set that is not countable. So the example of this one, we can consider the set of natural numbers. So this one, so we know the set of natural numbers is 1, 2, 3, and so on. So it goes to infinity. Okay, so these are the types of sets you should bear in mind. The empty set, the first one is the empty set, the second one is the finite set, the third one is the infinite set. So you should bear in mind there are those types of sets. Okay, so there is this concept called cardinality. Cardinality, you are being asked are the what is the size of the set. So what is the number of the elements inside the set? Okay, the size. So the cardinality, you are being asked what is the size. Okay, so the cardinality is the size, or you can say the number of elements in the set. Okay, let me just say in the set. So this implies to those three types of sets. So the empty set, the finite set, the infinite set. Okay, so let's consider this examples. Example one. So we have A is equal to 0, 1, 2. Okay, so what is the cardinality of A? So we denote the cardinality as something like an absolute. These two uh, these two lines. So we denote the cardinality as this. So the cardinality of A is what? So the cardinality of A is 3. So we have 3 elements inside A. So the cardinality of A is 3. Okay. So the second example, so we have B, which is an empty set. So what is the cardinality of B? What is the cardinality of B? The cardinality of B is what? Is 0. So for the empty set, we do not have any elements inside. So this is also written as like this. So we don't have any elements inside. So we call it an empty set. So the cardinality of B is what? Is 0. So the third one, so let's consider the integers. The integers, the set is 0, comma, positive 1 and negative 1, positive 2 and negative 2, positive 3 and negative 3, and goes to infinity. Okay, so what is the cardinality of the integers? So the cardinality of the integers is infinity. So these elements, they go to infinity. So we can say this is the first one, the second, the third, the fourth, the fifth, the sixth, the seventh element. Okay, and goes on to infinity. So the cardinality of integers is infinity. So that's the concept of the cardinality. The cardinality is the size of the set. Okay, you should bear in mind. So that's all for this video. Thank you. If you haven't subscribed, please subscribe. If you like this video, please show by clicking like and leave the comment if you have any comment. Thank you.